Okay, this problem says a projectile is shot at a hill, the base of which is 300 meters away. So there's, okay. The projectile is shot at an angle of 60 degrees above the horizontal with an initial speed of 75 meters per second. The hill can be approximated by a plane sloped at 20 degrees to the horizontal. Relative to the coordinate system shown in the following, the equation of this straight line is y tan 20 degrees x minus 109. So the equation of this line is tan 20x minus 109. So let's make sure that at x equal to 300, what should be the value of y? 0. Okay, so let's do tan 20 times 300, and that works out to 109. So this works out to, for that 300, so that is, okay, so that's the equation of this line. Where on the hill does the projectile land? Okay, so again, in this problem, the acceleration is 0I minus gj. V naught is 75 cosine 60I plus 75 sine 60j. Okay, so we have written our A's and G's. Okay, so now let's calculate okay, so let's say where on the hill does the projectile land. So we want this coordinate. Okay, so let's do the x coordinate first. X minus x naught equal to v naught xt plus 1/2 axt squared. That is 0. X is v naught x is 37.5 t. That's 0. Okay, that's equation 1. The y component of the motion is y minus y naught equal to v naught yt plus 1/2 ayt squared. That's 0. Y is 65t, and this is minus 9.8, so that's minus 4.9. Okay, there's that. Now here's the problem. The problem is we seem to have three unknowns, x, y, and t. Okay, and we can't solve for this. So we need a third equation, and the third equation is that this x, as long as the shell lands on the hill, this x and y are related like that. Okay, so there's the third equation. And also y is tan 20. I will evaluate tan 20. 0.36x minus 109. Okay, so there's the third equation. And now you have three equations and three unknowns, and you should be able to solve for that. Okay, so essentially, well, we have to find x and y, so we have to solve for t. And here's how we're going to solve for t. We're going to substitute, we're going to substitute this for x and that for y, and solve for t. Okay, so 65t minus 4.9 t squared that is y is equal to is 0.36x and x is 37.5 t. Okay, so now you see you have an equation only in t and you can solve for t. So there's a quadratic equation. Okay, so that is the solution we want. So it hits the hill 12.3 seconds later, and then we have to solve for x and y. Okay. Okay, so that's the location of the shell when it hits the hill. Okay. All right. So I will see some of you guys in lab. I'm sorry. For this chapter. No, there are more problems. So we'll finish them Tuesday and then start chapter 5.
What type of calculators are we allowed to bring to the exam?
You can bring a supercomputer.